Hello everyone, my name is Devinder Kaur and today we are going to discuss about power and the numerical problems based on power. So let's get started. Power of an agent is actually rate of doing work. So you can also say that power is actually the transfer of energy. So if we want to define it mathematically, because we want to calculate the power used up by a certain equipment or agent, then we have to define it mathematically. Since I had told you that power is denoted by P, okay. Since I had told you that power is rate of doing work, so we will try to define it mathematically with the help of this definition. So P stands for power is equal to the rate of doing work. That means work done over time taken. That means power of an agent is what amount of that agent has work done in what time. Okay, so that is the power. Now we all know that work done is equal to force times displacement. Okay, so I am going to put up this formula here. P equals Fs over T. Okay, now this is displacement upon time. Now displacement upon time is the value of velocity. So power can also be considered as force times velocity. So I have three mathematical expressions for power. Okay, I'm going to erase this circle here. Okay, so we have three formulas for power, and with the help of these three formulas we are able to calculate the power of any agent. Now let us talk about the commercial unit of power. Well, commercial unit of power is 1 kilowatt hour. Now what is this 1 kilowatt hour? It is the energy consumed by an agent in 1 hour, and the work done is in 1000 watts. The power is in 1000 watts or kilowatts. Actually the unit of power is, that's the unit of power, I forgot to tell you, is watt. Okay, so 1 kilowatt hour is 1 kilowatt stands for 1000 watt and into 1 hour. Okay, now we know that 1 watt, if we want to calculate 1 watt in terms of seconds, then how would we calculate it? Now power is here, it is measured in watts. Now work done is measured in joule and time would be measured in seconds in terms of SI. So I can say that 1 watt equals to 1 joule over 1 second. That means when 1 joule of work is done in 1 second, we can say we have 1 watt of power. So I'm going to take this value here. So it will be 1000 into joule over second. Okay, now I have this term in seconds, so I can convert this term in seconds, right? So now I'm going to convert it in seconds. Since 1 hour has 60 minutes and 1 minute has 60 seconds, so this is a 1 hour in seconds. Now I'm going to calculate it. 6 times 6, 3600 into 1000 joule. Okay, only joule is left because over second would be cancelled with second. Okay, so it can be considered as 336 into 10 to the power 1, 2, 3, 4, 5. So if I'm trying to convert it into the megajoule, so I can also take 10 from here. It will be 3.6 into 10 to the power 6 joule, which is considered as 3.6 mj. So it is equal to 1 kilowatt hour. Now there is some information about 1 kilowatt hour for you. Why do we use it? Well, kilowatt hour is also called board of trade unit or simply a unit which is used in households, industries and commercial establishments for measuring electric energy consumption. For example, if an electric heater of 1 kilowatt power is used for 2 hours, it consumes 2 kilowatt hour, or you can say 2 units of electric energy. Now it's time to solve the numerical problems based on power. In the first numerical problem, a boy of mass 40 kg runs up a flight of 50 steps, each of 10 cm high, in 5 seconds. Find the power developed by the boy. Now in this problem, the mass of the boy is 40 kg and the time taken by him is 5 seconds. Now let us try to determine the height. Now to determine the height, there are 50 steps and each step is of 10 cm. So we can calculate it as 500 cm, or in terms of SI, it can be of 500 over 100 equals 5 meter, because in terms of SI we use meter for height. So work done by that boy is mgh. Now mass is 40 kg, gravity acting is 10 meter per second square, and height is 5 meter. We just calculated. So work done here is 4 times 5, 20 into 2000 joule. Okay, now we are going to calculate the power consumed by that boy. So power is work done over time. So work done is 2000 and the time taken by the boy is 5 seconds. 2000 joule over 5 seconds. So it will be of 400 watt. So this is our answer. Now in the next problem, what should be the power of an engine required to lift 90 metric tons of coal per hour from a mine whose depth is 200 meters? Now the mass given here is 90 metric tons. 1 metric ton equals to 1000 kilogram. So it is 90 times 1000 kilogram, because we need to find it in kilogram as it is our SI unit. So it will be 9 times 10 to the power 4 kilogram. Now we are given the height and the time here is 3600 seconds, as we need all the SI units. Now work done by the engine to lift the coal is mgh. M here is 9 times 10 to the power 4, gravity acting is 10, times H is 200. So it is 1800 into 10 to the power 5. So we can say it is 18 times 10 to the power 7 joule. Okay. So we need to find the power of that engine. So power of that engine is work done over time. 18 into 10 to the power 7 over 3600 seconds. So it will be 200 here, and when the 200 will go up there, it will be 1 over 2 into 10 to the power 5. So 0.5 will be there. Okay, we can also calculate it as 0.5, that means 5 upon 10. So 5 into 10 to the power 4 should be the answer in watt. So it is 5 into 10 to the power 4. We can also say that it is 50 kilowatt, because if we take the 3 as the 1000, so it will be 50 kilowatt. Our answer, either this or this, both are true answers. Okay. So now let's move on to the next problem. In the next problem, how much time does it take to perform 500 joule of work at a rate of 10 watt? Well, this problem is very simple. In this problem, we are given with the work done, we are given with the power, and we need to calculate the time. So you remember this formula. So from this formula, I'm just simply taking up the values. 10 equals 500 over T. So the time here will be 500 over 10. That means time equals 50 seconds. So this is our answer. Simple as that. Calculate the units of energy consumed by 100 watt electric bulb in 5 hours. So in this problem we are required with the power of 100 watt. We are required with the time of 5 hours and we need to find the work done. Since we are trying to calculate the units, so we will try to get it in the terms of units, that means in the terms of kilowatt hour. So I am not going to change this time here. I will keep this time in hours now. Since from this formula P equals W over T, so I'm trying to find this one. So W equals P times T. Since this one is in watt, if I try to convert it in kilowatt, so I would have 0.1 kilowatt for this. So I will take 0.1 kilowatt times the time is 5 hours. Okay. So I have work done of 0.5 kilowatt hour, or you can say 0.5 units of power. Okay. So today we have discussed about the power, the commercial unit of power which is used by all of us, and the numerical problems based on power. If you found my video useful, then share this video with your friends and classmates and like my video, and if you haven't subscribed to my channel yet, subscribe to my channel. Thank you for watching.